In this example, we're going to determine the inverse function of f of x is equal to 4x plus 3. The first thing to do is to change out our function notation for y. I'll write that over here on the left-hand side. So we've got y is equal to 4x plus 3. The next thing that we want to do is we want to switch the inputs and outputs. It's kind of how inverses work. So I'll take my y and I'll replace that with an x. And then I'll take my x and replace that with a y. I now want to solve for the exponent position where the y is. To do that, I've written order of operations here on the right hand side for you. Normally, if we had a numerical expression, that's an expression with just numbers, we would go parentheses, do what's inside there first, then deal with exponents, multiplication, division, and finally addition or subtraction. When we're solving or unpacking an equation, we actually want to go in reverse order. So if we take a look at our expression to the right side of the equal sign, we're going to actually deal with the exponent last. And we're going to get rid of addition or subtraction, in this case addition, first. To do that, I'll subtract 3 from each side. So I wind up with x minus 3 is equal to 4 to the y power. I now want to solve for this exponent position, and this is where a logarithm comes in handy. I'll write the next step up here on the right hand side. So I can write log base 4 of x minus 3 is equal to y. I've now successfully solved for that new y. Remember, we switched the x for the y before. This new y is actually the inverse of f. So I'll use that notation. And that's going to be equal to log base 4 of x minus 3.